If you are working on 7.3 Reteach, or if you are needing more help setting up percent problems, then be sure to follow along with this video. So first, let's recap some information here that is important when we're solving these percent problems. So first of all, we need to remember that this word percent means per hundred. There's 100 cents in a dollar per hundred, and it always has to be connected to that hundred. So when we're given the information, we want to set it up in these proportion problems. And our whole number is always going to be across from 100. If I got 10 out of 10 on a test, that would mean I got 100%. There are 10 whole problems on the test. Well, that would be 100%. So then the percent should always be above the 100%, over 100%. And then the part that you have, so if I only got 7 out of 10 on the test, the part I got correct is here. The whole test is on the bottom. So notice the parts that I have line up, the wholes line up. The test lines up, or whatever you have lines up, and the percent lines up. So everything has to be connected to the right thing here. So we're going to take a look at a couple problems and substitute the information in to the right place here. So actually, let me go ahead and grab a picture of this part right here so we can substitute that in the right place. So let me grab this and let's come and look at these problems here. So we are starting with what percent. So we're looking for the percent. This is the one we're looking for. What percent? So we're looking for this of 180. When we're hearing this word of, that's going to be our bottom number of the whole thing. And if I have this percent, it is this much. So is going on top, of is going on bottom. Of is the whole thing. So we're looking for the percent. What percent? Remember, percent is always over 100. Of 180. So here's 180. That's our whole thing. Is 45. So if I have 45 out of 180, what percent is that out of 100? So we can move 100 to the other side by doing the opposite of divide, which is to multiply. So 45 times 1 is 45 with two zeros here. And then we're going to take that and we're going to divide by 180. So I know it can't go into 4 and it can't go into 5. And so let's see, if I have 180, next is going to be 360. 360 plus 180 is 0, 14, 540. That's too big. So it goes in there 2 times, which is 360. So we're left with 0, and we need to borrow here. And 15 minus 6 is 9 with a 0. So we're at 540 here. So let's keep on adding another group of 180. So there's 12, 720, 720, and 180 is going to make 900. So here's 720. 900. So it goes in there 1, 2, 3, 4, 5 times exactly. So if I had 180 marbles and 45 of them were blue, that would mean that 25% of them, a quarter of them, are blue. So I think if we simplified this, this would actually equal 1/4 here, 25%. Okay, so let's try setting up this one over here on the right. So on a softball team, we have 8 players that are 12 years old. So we don't have 8 out of 12. 8 people are 12. 50% of the softball, if 50% of the softball players are 12 years old, how many people are on the team. Okay, so let's think about what we know here. So here I see a percent. So let's plug our percent in. That's always an easy one to start with. 50%. And we know that we have 8 people that are 12 years old, and the 12-year-olds are 50%. So the 8 people are going to be connected to 50 here. So 8 of the players that are 12 is 50%. So notice how it said the 8 people are 12, the 12-year-olds are 50. So that's connected, and there are 8 12-year-olds. So it's important that we get that right number in there. So this number 12 is just telling us how old they are. It's not actually going to be part of our problem. And so we're looking for the total number of players on the team. So we're going to do 8 times 100 is 800. And then we're dividing that by 50. So that goes in there one time, which is 50. There's 300 left over. So 50, 100, 150, 200, 250, 300. So that goes in there 6 times. So this tells me that there are 16 people on this softball team. So one thing to notice is that 50 is half of 100. 8 is half of 16. So they both followed those same patterns. Okay, let's try one more here. So I'm going to grab that for us. We need to find the parts that we know and plug them into this formula here. So in a class, 10 students like salad. If 40% of the students like salad, how many students are in the class? So 40% like salads, 40% is 10 students that like salads. So let's start with our percent. So 40% always over 100. And we know that 40 is 10. So these should be connected to each other. And then we're looking for the total number of students in the class. So 100 times 10 is 1,000. And then we're dividing by 40 here. So it can't go into 1 or 10, but it can go into 100 2 times, which is 80. And then there's 20 left over. Bring down the 0. So 40, 80, 120, 160, 200 is 5 times. So it looks like there are 25 people in the class. So we can see 25 is smaller than 100, 10 is smaller than 40. So the patterns follow the same direction. 100 is bigger than 40, 25 is bigger than 10. So they follow the same patterns every time. So as you're working on these problems, use this formula here if you need to and decide what is your percent if it tells you that. And you're always going to have this number. You're always going to know that this is 100 here. So you've got to decide, do we know the percent? In this one we did. Do we know the part or the whole? So this one asks how many students are in the class. That's a total, which has got to go on the bottom. So we're looking for this. It's asked us that question. It told us that 10 was connected to 40. So those should match up. So each time use this formula, plug in your numbers, and then you can crisscross multiply and divide. Hey, let me know if there is anything I can do to help you.